In this video, we are going to talk about piecewise functions. So what is a piecewise function? So a piecewise function is a function which may be defined by two or more different equations. Okay, so now how do you get to sketch a piecewise function? So a very good example is a function that we've been given. It's defined by two equations. So in short, you have that one and this one. So now, how do you tell how to sketch it? So you have a domain that is going to be guiding you. So in this very one, we are going to sketch it. So that's our y, this is our x. Okay. So how do we sketch it? So we'll come up with a table of values for the first one, where it is 2x plus 3. So that one is applying to the values of x which are not equal to -1. So for the function y is equal to 4, it is only applying to where at a point where x is equal to -1. So at a point where x is equal to -1, y is equal to 4. So 4 is somewhere there. So meaning that you have a point there. You only have a point at -1 where y is equal to 4. Because remember, a function is y is equal to 4. How about the other equation which is saying y is equal to 2x plus 3? So what one is, they are saying all the points are not equal to -1. Okay, so you can sketch that now. So it's a linear function, remember. So we'll start with 0. So where there is x, we put a 0 plus 3. What we have is 3. We can try 1. So where there is x, we put a 1 plus 3. What do we have? We have a 5. So at a point 0, we're getting a 3. So 3 there. Then at a point where we have 1, if you plug in that function, we're getting a 5 somewhere there. Then how about -2? Because, so it's like going this side and going to the right of a point -1. The only thing that is defining y is equal to 4 is only x is equal to -1. All the other x values are going to be defined by the other function there. So if you plug in -2 in that function, at that point 2 times -2 is going to be -4 plus 3 is going to give us -1. So somewhere there, -1. So to sketch it, we'll use this. So let us draw that line. So this is the way it's going to move. Then at the point where x is equal to -1, it is going to skip and continue after. Like that. So this point is defined by y is equal to 4. So that's how you sketch a piecewise function. So now let's say under this same piecewise function, you are asked to determine some of these things. Let's say they ask you to determine a function of 4. How do you do it? So what you need to do is you need to ask yourself, this is the value of x. So which of the two equations is defining 4? So the first one is only, the second one, sorry, is only defining only x is equal to -1. So 4 is obviously going to be part of the other equation. So it's therefore going to be 2, 4 plus 3. 8 plus 3 is going to be what? 12. Now let's say you have this piecewise function. You're asked to sketch it. How do you sketch it? So all these are linear functions. So in this case, we have been given different domains. For the other one, we are told it's moving from, it's all the values that are less than 0, and this one is starting from 0 going up. So we have our graph there. So this is our y. This is our x. Okay, so we'll start with the values of x that are less than 0. So starting from -1, -2, going there. Alright, so what happens if we plug in -1 in that equation? So it's going to be -1 plus 1, which is going to give us what? So that is going to be a 2. So for -1 we have a 2 somewhere there. How about if you plug in a -2 at that point? It's going to become a +2 plus 1, which is going to give us a 3. So somewhere there. So 3 is going to give us a +3 there, plus 1, which is going to be a 4. So the function will just be going up. So it's a linear function. So it's therefore going to be going up there. So it's starting from a point just after 0. Okay, so I can sketch it. So at a point after 0 there, and that's the way it's going. All the points, all the values of x. So we are saying all the values of x that are less than 0, and they are starting, and that means that you're talking about the negative numbers. So that's the way you sketch the left part of the piecewise function. Then how about the other part? So this one they are saying it's defining the function all the way from what? From a point 0. From a point 0. So what happens? What happens? So you need to look at the function now. Okay. So you are starting from 0. So at a point 0, where if you plug in 0 at this point, you have a -1, which is going to be somewhere there. So that other function is starting from here. At 0, it's giving us -1. How about at 1? What is it giving us? So if you plug in a 1, 1 minus 1 is going to be a 0, so it will be at that point. You plug in a 2, 2 minus 1 is going to be a 1, somewhere there. Just like that. So that's the way this function is going to be moving. So it's going to be going up. So it's defined starting from a point where x is equal to 0, so like that. So that's it about the piecewise function. It is defined by different equations. So now let's say they asked you to say, determine whether this piecewise function is continuous. So if you want to determine whether a piecewise function is continuous, you look at the endpoints. So where are they being separated from? They are being separated from a point 0. So I'll plug in 0 in that first equation. It's going to give me what? It's going to give me 1. Then in this one, it's going to give me -1. So whenever the values are different, it means that the two functions are the function is discontinuous. So it's discontinuous, as you can see. It has ended there, then again it has started from a different point. So it is discontinuous and not continuous. Okay. Now let's say you have that piecewise function. G of x is defined by 3 equations. You've been given the domain for the first one to be the values of x that are less than 3. So let's try to sketch it. So this is what you have. Okay. So that is your y, and this is your x. So let's come up with the values of x. So that one here is being defined from the values of x that are less than 3. So let's try to move this line a bit. Okay, this side. Alright. So x is less than 3. So we get 3, maybe let's just put it somewhere here. So going this side, all the values of x are defined by the first function. That's what it means. So we can sketch it. So what happens if you plug in 3 in that equation? So at the point where you have x, you put a 3. So it's going to be -3 minus 4, which is going to give us -7. You plug in 2. going to be -2 minus 4. It gives you what? -6. You plug in -1. You plug in 1, sorry. It's going to give you -5. So since it's a linear function, with just 2 points is enough to draw it. So a 2 and a 1. So for a 3, it's giving us -7. So let's say -7 is somewhere there. So that's where we have -7. Then 2 is giving us -6, let's say somewhere there. Then 1 is giving us -5, let's say somewhere there. So when it comes to sketching it, this is the way it's going to come out. So something like this. Like that. So it's ending at a point where x is what? Where x is equal to 3. Somewhere there. Okay. So it will be going up like that, because all the values that are less than x, less than 3, are defined by the first equation there. So you move to the second one. So it's a quadratic function, x squared minus 7. So it's alright, so just before we even move on, so it was the first one is x less than 3, so 3 is not included. So let's try to remove this part of the function. So it's only ending somewhere closer to 3 and not 3 itself. Somewhere just a point before 3. That's what is being defined by the first equation. So the second equation is defining now from point 3 up to 10. So we can look at 3. What is it going to give us? So 3, if you plug in that equation, 3 squared is going to be 9. 9 minus 7 is going to be a 2. So somewhere there. Somewhere there. So by just looking at the way it is, it's a minimum. So if you want to know how to sketch a quadratic functions, we have got a video on that. So the minimum point, we can determine the minimum point in this case, which we can just say is going to be given by -b over 2a, where our b in this case is what? We don't have a b, so it's 0. Our a is, so we have a 0 there. So if you plug in 0 in that function, your value of y is going to be what? -7. So -7 is the minimum value. Somewhere there. So it's going to be 0, -7. But 0 is defined by the other function there. So it's kind of something that is starting from here and going like that. Okay? So it was supposed to go this way. So I'm showing the dotted lines because it's not part of the sketch. So how is it going to be moving if you plug in the other values? If you plug in a 4, 4 squared minus 7 is going to be what? 16 minus 7, which is going to give you 9. So this graph will be going just up like that. Okay, so we end up to 10. If you plug in 10, 100 minus 7 there, it's going to be something like 90 something. So that's where you are heading for that function. So you can even show it. This one is -x minus 4. So -x minus 4. Then this other one, we are saying it is y is equal to x squared minus 7. So somewhere at 10. Okay. And it's somewhere 97. You can show it. So 100 minus 7 is 93. Okay, so yeah. So how about this other one now? It's defining x squared minus 2x. All the values starting from 10. Greater than 10. So you can try out maybe 20. If you plug in 20 there, it will be 400 minus 2 by 10, which is going to give you 20, something like 300 and something. So somewhere up there. So by a sketch, you can just show it. So 10 Should be somewhere on top. Yeah. Yeah, then you show it's there. Okay. So it's also supposed to be a quadratic function. So you can check out how we sketch quadratic functions. That is not our focus in this video. So then they can ask you a question to say, determine whether the function, the piecewise function, is continuous or discontinuous. So we look at the endpoints of the graphs. Okay. So we'll start by looking at the first one. The first one, okay, let me just have the equations back. All right, so that's where we have our equations. Let me now try to remove this. Let's see. Okay, so we have our equations there that are part of a piecewise function. So I'll start from between the first one. So the endpoint is 3 and 3. So I'll plug in 3 in the two functions. So for the first one, it's going to be negative 3 minus 4, giving us negative 7. Then for the second one, which is x squared, is going to be 3 squared minus 7. So 3 squared is 9 minus 7 is a 2. So whenever the values, the endpoints are different, it's discontinuous at that point. So you can also try out the other one. You plug in 10 there in this function, which is going to be 10 squared minus 7. 10 squared is 100 minus 7 is 93. You get the other one. 10 squared is 100 minus 2, 10 there. You have what? 80. So even these are different. So even at that point, 10, the two piecewise functions are what? The equations of a piecewise function are continuous at that point. Then finally, you've got another piecewise function there. So given that the values of x less than negative 3 are defined by that equation, so what we have here, we need to understand, is a piecewise function. It's a single function defined by more than two equations. Okay, so when they say determine h of 1, you need just to plug in the function there. So you need to understand where you should expect to find 1 as a value of x. So if you look at the domains that we have on the right hand side, where is 1 falling? So 1 is at this point where x is equal to 1. So that is less than 1, so it's not. And this is just saying 1 is less than x, it's not. So the only equation defining x is equal to 1 is y is equal to negative 2. So you have h of x being equal to negative 2. So at that point, there's nothing like no plugging in. It's only a negative 2. So it's a line. So therefore, h of 1 is going to be what? Negative 2. Okay, so if we add the x somewhere there, for example, negative 2x would have plugged in and said negative 2 by 1, which would have been negative 2. Just like that. Okay, the second one says h of negative 1. So where do we have negative 1? So when they say x is less than negative 3, is negative 1 less than 3? No, it's bigger. So this one is saying between negative 3 and 1. So do we have negative 1 between negative 3 and 1? Yes. So we are going to use that equation, which is saying h of x is what? X plus 3. You plug in negative 1. So negative 1 plus 3, which is giving us what? Which is giving us 2. Alright. Then the last one says determine h of natural log of 2. H natural log of 2. So natural log of 2, where is it? It's part of this one, where y is equal to e to the power x. So we need to plug in now. So e natural log of what? Natural log of 2. So if you get your calculator and plug in that, your value is going to be what? 2. Okay. So that's it for this video. I just hope that you understood how to deal with the piecewise functions and what they are. Thank you very much.